Bismillahirrahmanirrahim. So there are two types of cellular phones: handheld, represented by H, that you carry, and mobile phones, represented by M, that are mounted in vehicles. Phone calls can be classified by the traveling speed of the user as fast, F, or slow, W. So monitor a cellular phone call and observe the type of telephone and the speed of the user. The probability model for this experiment has the following information. Probability of F, that the probability that the user is fast, is equal to 0.5. Probability of handheld phone that is fast, HF, is equal to 0.2. Probability of the mobile phone which is slow, that is probability of MW, is equal to 0.1. So what is the sample space of the experiment? And calculate the following probabilities. Probability of slow phone, probability that the phone is slow, probability W. PMF, probability that the mobile phone is fast, that is fast, and probability of a handheld phone, cellular phone. So let's first find out the sample space of this experiment, which is quite easy to find because the phone can be either handheld or the mobile phones mounted in vehicles, and similarly the phone can be either fast, user can be either fast, or it can be slow, right? So the sample space has four elements. Handheld phone which is fast, handheld phone which is slow, mobile phone which is fast, and the mobile phone which is slow. So this gives us the sample space of the experiment. Next we need to calculate some probabilities, and we are given some probability model. For example, we are given that probability of phone being slow is 0.5, probability of a handheld phone and which is fast is 0.2, probability of MW is 0.1. So what we can do is we can quickly build a table like this, right? So phone can be handheld, right, and it can be mobile. Phone can be fast, user can be fast, or it can be slow. So we are given that phone fast, the probability of phone being fast is 0.5. So this is 0.5 here on the margin, right? HF is this, this is 0.2, and MW, M and W, this is 0.1. So the probability of a fast phone is 0.2, fast phone is 0.5, and probability of a handheld phone which is fast is 0.2. So the sum of these two probabilities here should be 0.5. So this is 0.5 and this is 0.2, so it means this should be 0.3, right? So probability of a mobile phone is 0.4 here. Now the sum of these probabilities should be 1. These are marginal distributions. So probability of fast plus probability of W is 1. Total is 1 here. So this should be 0.5 then. Phone can be either fast or slow. So the probability of fast is given as 0.5. So the probability of slow is 0.5 also. So now the sum of these two probabilities should be 0.5. So this is 0.1. So it should be 0.4 here, and similarly we can calculate this probability here. This is 0.6, and note that this 0.6 plus 0.4 is again 1. These are the marginal distributions. So this is the probability of phone being handheld, and this is the probability of a phone being mounted in vehicle, cellular phone mounted in vehicle. This is the probability of phone which is traveling fast, user is traveling fast, and this is the probability that user is traveling slow. So with the help of this table, we can find out all the probabilities. For example, this B, probability of W is 0.5, as you can see from here, and probability of MF is 0.3. It is this, right? Mobile phone, which is fast, right? And D, probability of handheld phone is this probability, 0.6. So if we look at this problem in another way, this can be solved, for example, in an alternate manner using the mathematical method. So we are given that probability of fast phone is 0.5. So phone can be either fast or it can be either slow. So the probability is 1, right? So the probability of phone being slow is 1 minus probability of fast phone. So that is probability of slow phone is 1 minus 0.5, and that gives us probability to be 0.5. Again, the same value. This was the part B, right? And in part C, we needed to find probability of MF. Probability of MF, right? So the probability of fast we have already found is given by probability of HF plus probability of MF. Probability of HF plus probability of MF, and we need to find this probability, right? So probability of is given, this is 0.5. Probability of HF is also given here, this is 0.2 here, right? So 0.2 plus probability of MF. So probability of MF is 0.5 minus 0.2 is 0.3. Again, the same value. And now for the part D, we need to find out probability that the phone is handheld, right? So probability of phone being handheld plus probability of phone being mobile is equal to 1. It can be handheld or mobile, so the total probability should be 1. So if we find probability of being mobile, we can find the probability of handheld phone. So probability of a phone being mobile is probability of mobile phone which is fast and probability of mobile phone which is slow, right? So we have already found out probability of MF here, 0.3, and probability of MW is given, right? Is given as 0.1. So probability of mobile phone PMF 0.3 plus this value was given as 0.1. So probability of phone being mobile is 0.4. So that means putting this value here, probability of handheld phone is 1 minus probability of M. So probability of handheld phone is 1 minus 0.4, and that comes out to be again 0.6. So in this way also we can determine the probability. So yet another way, alternate way to solve this problem will be to actually build a tree for the problem, right? So yet another alternate method. So we are given that a phone can be either fast or slow, right? So that probability is given. So we can start with building the tree with these two branches, fast and slow, right? Fast and slow. Now the fast phone can be handheld, right? It can be handheld or it can be mobile. Similarly, this slow phone can be handheld or it can be mobile, right? So this is the probability the phone is slow, and we are given that this is 0.5. This is the probability of phone being fast, and this is the probability of phone being slow, right? And this here will be the probability of handheld phone given that it is fast, and this will be the probability of mobile phone given that it is fast. And this is probability, these are the conditional probabilities, right? These second branches, these are conditional probabilities. So this is the probability that phone is handheld given that it is slow, and this is the probability that the phone is mobile given that it is slow, right? And we are given certain probabilities. For example, we are given probability that it is fast is 0.5, and we are also given probability HF, probability of HF and probability of MW. Now this here is probability of HF, right? Probability of HF, because you see this probability HF is equal to probability of H given F multiplied by probability of F, right? And this here is probability MF. This is MF, right? M and F. And this is probability of this probability here and this probability of M given F multiplied by probability of F. This is probability HW, and this is equal to probability of this probability of H given W multiplied by probability of W. Similarly, this is probability MW, and this is equal to probability, this probability multiplied by this probability of M given W multiplied by probability of W. So now we are given this value, probability of HF is equal to 0.5, right? And we are also given this probability of MW is equal to 0.1. So probability of MW is also 0.1. So we can then calculate from this probability of F is also known, so this is 0.5, so we can calculate this probability H given F here, right? So from this relationship, right, probability of HF is equal to probability of H given F multiplied by probability of F, and this is 0 point, and this is actually probability of F is 0.5, but probability of HF is 0.2. So this is 0.2 here, sorry, 0.2, right? So this is 0.2. This value is 0.5. So 0. Probability of H given F is found out to be 0.2 divided by this value 0.5, right? So probability of H given F is 2 over 5, which is 0.4. So you see on this tree we know this value, we know this value probability here, so we have then calculated this value. So once this is known to 0.5, so 0.5 plus this should be 0.4 plus this should be 1, right? So this is 0.4, then this is 0.6. So we can write it like this: probability, therefore probability of this is H given F, then probability of M given F, it should be 1. So probability of M given F is 1 minus 0.4, that is 0.6. So we have calculated this probability to be 0.4 and probability of M given F to be 0.6 here, right? Likewise, we know that this probability PMW is 0.1, right? So we can go on to calculate these probabilities, and from here also first we note that this probability of first is 0.5, so these two probabilities should be the sum of these two probabilities should be 1, so probability of W is also 0.5 here. So this is 0.5, right? Probability of first plus probability of W is 1, and so probability of W is 1 minus 0.5 is 0.5. So probability of MW is equal to probability of M given W multiplied by probability of W. So probability of MW is given to be 0.1. So probability of M given W multiplied by 0.5. So probability of M given W is 1 over 5, that is 0.2, right? So we have calculated this probability of M given W to be 0.2 now. So this should be 0.8, right? Because probability of M given W plus probability of H given W is equal to 1, right? And probability of M given W is found to be 0.2 plus probability of H given W we need to find, and this is equal to 1. So probability of H given W is 0.8. So this is 0.8 here. So now it is easier to calculate these two probabilities also. So this is equal to 0.6 multiplied by 0.5. So this should be 0.3. Similarly, this should be 0.8 multiplied by 0.4, and this is 0.5. 0.8 multiplied by 0.5, so this should be 0.4. So you see, if we add these all probabilities together, this comes out to be 1. So this is a check, and this this confirms that our solution is correct. So writing it here, we can actually write probability of MF is equal to probability of M given F multiplied by probability of F. So M given F we have already found out, 0.6, and probability of we already know, 0.6 into 0.5, so probability of MF is 0.3, right? And similarly, probability of HW is equal to probability of H given W multiplied by probability of W. So probability of HW is, so H given W is found out to be 0.8 and the probability of W is 0.5. So probability of HW is 0.4. So from this tree again, we can find out all the required probabilities that we are asked. So probability of W is 0.5, right? Again, and probability of MF from the tree we found out to be 0.3, and the part B was probability of handheld H. So probability of H, right? So the probability of H is actually given by this probability of HW plus probability of HF. Probability of HW plus probability of HF. So probability of H is equal to probability of HW is 0.4 and this is 0.2, so this is 0.6. So this concludes our solution to the given problem.